Okay, I think in the interest of time, we'll get going. Hi, everybody. Happy April. It's very hard to believe we're already this far into 2024. Welcome to the April monthly InHealth showcase. We're really excited to have two of our superstars of the InHealth program here today with us. First, we have Dr. Ryan Ramich, who is an assistant professor of physical medicine and rehabilitation and is a human movement scientist at Kennedy Krieger. Ryan has done a lot of really interesting personal work. He also directs the Rehab Precision Medicine Center of Excellence and is leading the digital monitoring subgroup, where like-minded people who are interested in thinking about digital monitoring within their precision medicine efforts can gather to talk about some of their approaches. And we likewise have the extraordinary Bill King. Many of you know him as a project manager within the Technology Innovation Center. Bill has been responsible for many of the successes so far in the InHealth program. But perhaps most exciting is the work he's going to present today about wearable labs. And of note, he was given the awarded the 2023 Microsoft Innovation Acceleration Award for his work. So Bill and Ryan, thank you so much for joining us. We're super grateful, and I'm sure everyone's really excited to hear what you have to say.
Thank you for that, Ellen, and I'll get started. So, 3 things about me. You'll be more familiar with my dog than me, Daisy, since she is my avatar. So when I stop sharing, that's what you'll see, sharing my my video. I'm married with 2 kids, and as now you're aware, and a dog. And I jumped out of the second plane I ever flew in, which is always an interesting topic. So 3 things about my professional area. In the TIC, our job is to make you successful. So my role is both a product manager and a project manager, but really it's a fancy way of saying that I build stuff to help you succeed. And that's what I aim to do. So I'm going to do a demo of Wearable Labs, then cover our product roadmap. Then if you could please hold questions until the QA session happens after or follows Ryan's presentation. So with that, I'm going to jump to do a demo. But before I do the demo, I want to make sure I call out that Wearable Labs started from a work that Sharon and Ryan were doing about tracking Fitbit data. And so they built the precursor system that Wearable Labs is based on. So I took that with the great work they did, and said, okay, let's kind of take that to the next level. And that's what I've been working on. And that's what has now become Wearable Labs. So can everyone now see my browser screen?
Yep.
Great. So I'm going to walk end to end from creating a new study, editing, making the changes to the draft, launching it, then showing how you provision a participant, provision a Fitbit for them. And then I'll jump over to a PowerPoint just to show the screenshots of what the mobile app experience looks like for the participant. And I'll come back to the screen here, and then one more slide, and then Ryan will take over. So this is the main dashboard list of studies as you've observed. Now to create a new study, you would simply enter in the IRB number for your study. And we do have some controls in there such that if you're entering this in here, we're going to do a lookup on eIRB, but you have to be on the protocol in order for it to return something. So again, we're not going to allow people just to look at anything or create a new study from things that they're not actually on. So if you were to put that in there, it would return a result, and it would basically ask you to confirm, is this the study you want to add to Wearable Labs? And you'd say yes. So in the interest of time, I've already created a draft study, so we can run through it more quickly. But the 3 main areas you're going to fill out when you start using it is there's details, device, instructions, and communication. So the general details are things like putting a more user-friendly study title, because oftentimes those names are very long, but we want you to use a shorter one because this is what will be visible to the participant in the mobile app. And you put in study duration. So this really what that means is how long do you want to be collecting data for each participant? Because we want to make sure we enforce the rules so that If they've already completed the number of days that you said, or months or period you're going to be collecting data, we'll automatically stop that data collection so we can stay within the regulatory constraints. And you put how many participants you want to recruit and contact details. This is information that will also again be displayed to the participant in the mobile app. And lastly, our study team members. So when we retrieve the study from EIRB, it's going to give us everyone who's on the study. We don't automatically give them access to the study in Wearable Labs. You pick and choose who you want to have access. And if someone is removed from the study in EIRB, their access will be removed in Wearable Labs automatically. Next comes the device selection. So right now we're just about to launch in a week or two, and we only have support for one device, Fitbit. When you select the Fitbit, your next decision is to decide what device metrics or scopes or observations do I want to collect for this study. And you simply would select these, and whatever's listed here is what is going to display in the mobile app for the participant to consent to. And we have these two, profile and settings. Those are ones that we don't really fully use. We use a little piece of it to help us make sure we only get the data, make sure we can calculate compliance when the last time we got data from them and those sorts of things. That's why they're grayed out, because you're always going to need to use those because the system needs to do that. Then you decide device ownership. Is it only going to be study provided, or are you also going to allow BYOD? And I know Ellen will be excited to hear this, but right after our release in a couple of weeks, we're going to be working on the ability to do a kind of a BYOD study, which is really for registries. So you'll be able to send an email out via MyChart, and participants who are BYOD, have a Fitbit, will be able to self-enroll and consent without you having to do anything. Lastly, you're going to define the frequency. What is your expectations of when you're going to get data from this device? So Fitbits or activity trackers, your expectations, you want to get it daily. Next are links to instructions. This is just a digital version of the paper version you historically have given the participants about the study. Again, this is going to be a link and available to them in the mobile app. Lastly are the messages or communications that go out. So first is the welcome message. And I'll note that I put the name of the study in the subject field because we're doing testing, and it helps us identify the study, what was the source of the email. You won't be putting the name of your study in the subject field. You can put it in the body of the email. But so don't take what I've done here as that actually according to the policy, it's not, that this is for testing. And we're also going to be adding the ability to not only do email, but SMS text as another channel of option. So the welcome email will go out to the participant when they're first provisioned the device. Off study, well, if the status changes in upstream of us, we get our data from Epic, but CRMS and Encore also are feeders into what we're getting. If their status changes to that, we'll automatically send this email. Or if you said you're going to collect data for 12 months and you now collected data from them for 12 months, we'll automatically stop collecting data and send the off study message to them. And then lastly, there are the engagement reminders. This is an automated way to reach out to them if they're out of compliance, if they're not wearing the device, if they're not syncing it, or whatever you need them to do with the wearable device. And the keys to this are defining down here. So when am I going to send the first reminder if we get no data? So in this case, we're saying 3 days no data, we're going to send the first version of this. And you have the option to continue doing that if they're still out of compliance. So this is key because we want to try to, so you can scale the larger studies. We want to handle a lot of as much automation and outreach as we can for you, so you can focus on higher value priorities. The last step you do with launch, I won't do it here for the demo, but when you do this, you're actually now, the study's going live and it's retrieving all your enrolled participants from Epic. So let's go to what would be a live study. So when you first create the study, unless you have some of that are off study or withdrawn, you will, almost all of them will be new. And when you have this new participants, you'll go here to provision to them. And I'll go to select my AA test, do Fitbit, and you will then determine, is this a study provided device and account? If it is, you'll be filling in serial number, and that's really more for your own inventory tracking if you're expecting to get the device returned to you. And then the account and password information, it's for Fitbit account, or as of June of last year, Fitbit stopped allowing you to create new Fitbit accounts. You have to do Google accounts. But here's where you put that information. And these two fields here would show up in the mobile app of the participant to help them to be able to onboard by themselves without any assistance. And of course, I went BYOD. This matters because they already have a device and an account. And if I hit save, that'll fire off the welcome email. And I won't do that here. And it'll change their status from new to ready. Ready simply means that they're ready to onboard. We've sent them the welcome email and they're all set. Some other information you can get from here at the study level are study progress. We see a breakdown by status and the overall compliance rate. Because we only support one device, these figures will be the same. But when we add multiple, you can imagine this would be a different value here. And then study details where you can go and edit the study once it's gone live. So now I'm going to jump over as if I was a participant, and I'll show you what that experience looks like in the mobile app. And let me know if everyone can see the PowerPoint screen now.
Yes, we can.
Great. So the welcome email will have links to the app stores, and you can have links to instructions and other information in there. But the first thing they'll be instructed to do is download our mobile app. They'll do that, and then they'll log in using their MyChart credentials. And once they've done that, they'll be presented with a note about data privacy and security, and about accepting notifications from our mobile app, the Wearable Labs mobile app. Then they'll get to the homepage and they'll have their tasks. And their first task here will be set up Fitbit. So this one, I'm assuming, is going to be a BYOD participant. So they'll simply have one step and they'll authorize consent. And I'll take that to the step in a second. But if this was a provided participant, they'd have a few more steps to do here. And we would also include that account ID and password that you created for them. That will be displayed here. And there again is a link to the instructions that you also saw previously. Here they would log into their account using, again, their credentials. And they would consent to the study to share the data. And what this is really doing is they're consenting to share their account data with these scopes, or observations, or metrics with the study. And we're also generating tokens so we can automatically retrieve the data in the background without anyone have to re-log in or you have to do anything. It then becomes automatic. And then they're done. And then once they're done, then at that point, I'll return back to the browser. And can everyone now see that?
Yes.
Great. So once that's happened, they would have gone from ready to active. And we'll start collecting data from them. Now, if you recall, I mentioned there's the automated engagement reminders. We have the first reminder and second reminder. If both of those have not worked, so after the automation has run its course, only then will we put an alert here to let you know that that hasn't, that they're still out of compliance after that. Because the goal again is to minimize the things you have to do. So we want to let the automation run its course. If that doesn't work, then you can take more of a TLC approach of how you're going to reach out to the participant. And you'll be able to know that by seeing that they have this alert next to their name on the main study dashboard. Now for each participant, you can also drill into additional details. So this information is all pulled from Epic. We'll also see device details. So in this case, this was a study provided one. And then communication. Sometimes people say they don't get the welcome email, so you can resend it from here. It went to their spam folder or something. And then you can also pause those automated reminders. So let's suppose a participant, they lost their Fitbit, it broke, or unfortunately maybe you're hospitalized. We don't want to keep sending those notes to them and just annoy them to no end. So here's where you can disable that. You'll have the option to disable for, pick a time period. So we stop sending the nag notes to them. So that completes the demo. I'll go back to one more slide. So thank you for patience while as I jump around here. And if everyone can see that. So here's our product roadmap for the end of this year. So we're going going live soon. And we're going to start working on registry support and mobile consent. So again, that's where you will be able to, for your registry, you'll be able to send a MyChart message to them with links to the app stores. And if the participant has a BYOD, they have their own device, they can then self-enroll and handle consent all in the mobile app. And then you would track it just like you saw the other study we just looked at in the Wearable Labs dashboard. Then we're going to start tackling historical Fitbit data. So again, back to a BYOD, if someone's BYOD and they have 3 years worth of data, then you don't want to have to wait 3 years to get that data. What if we can get that this week? So we're going to allow that as an option if you want to go retrieve that data. So I would recommend any of you, if you're going to be putting together in your e-forms and other IRB documentation, make sure you also want the option to include historical Fitbit data. And I also have some boilerplate language for you to use in your e-forms and consent forms and so on that we'll provide, and we'll have a link to that later that we'll send so you can get started right away. And then multi-site and REDCap support. So then now new devices, this is where your role comes in, because we have a survey that we're going to send you a link to, where your feedback is really valuable to help us figure out not only that, but other things and directions we want to take the product. Again, the idea, I want your feedback because we're trying to help you become better and more effective. So that's why 10 questions, 5 minutes max. Then how do you stay in touch? Well, the wearablelabs.io site, just come here and put your email addresses in here, and then we'll make sure you're the first to know of anything new that comes up. And with that, I will share or hand over to Ryan, allow him to host. And thank you again for your time and watching and your support. We appreciate it very much.
A
Awesome.
reminder, we'll take questions after Ryan's portion, and you can put those in the Q&A and if you'd like.
Perfect. Thanks, Bill.
You should be able to share now.
Cool.
Your screen.
Okay, it looks like it's showing up. Can everybody see that okay?
Yes.
Perfect. So yeah, first, before we get started, I'll just return the thanks to Bill and the rest of the folks at the TIC who've been working on this with us for several years now. Bill gave a great demo on essentially how you use Wearable Labs. Today, I'm going to talk about how we've really benefited from it and show you some examples of the types of data and types of analyses we've been able to do using the proof of concept version of Wearable Labs. So thanks again, Bill, and the rest of the TIC team. As is tradition with getting these sessions started, I'll do my 3 things about me. So I'm married with 2 kids, and I've actually met Kate Fitzgerald, who's been presenting on a couple of these previously, because our kids went to daycare together in what I'm calling here the Hopkins PIDCO, the Precision Daycare Center of Excellence, just down the street. I'm originally from a really small town in rural Nebraska called York, Nebraska. And unfortunately, along with that, I'm a longtime suffering fan of the most futile athletics program in men's college basketball, which is the Nebraska men's basketball team. 3 things about me professionally. I have a little bit of a professional identity crisis because I bounced around in my education, my training. I'm an engineer by undergrad, but then I did a PhD in a physiology and kinesiology program, but largely working in a movement disorders center at the University of Florida. I've been here at Hopkins and the Kennedy Krieger Institute for a little over 10 years. I did a neuroscience postdoc here at Hopkins and the Kennedy Krieger Institute, and I've been in the Department of Physical Medicine and Rehab since 2017 as a faculty member. Most of you probably know me through my role as the director of the Rehab PIMCO, but we also do a couple other things. I run a 3-dimensional motion analysis lab over here at the Kennedy Krieger Institute, where we work on a variety of different motor rehab studies. And we also do a lot of computer vision work. So working on trying to make it as easy as possible for anybody to get a quantitative, objective, and accurate movement assessment using nothing more than kind of household recording devices. And so I wanted to make a pitch. We are a really collaborative PIMCO. We love working with people from the other PIMCOs throughout Hopkins and beyond. So basically, if you want to help us do something cool and are useful, I hope you'll contact me and we'd love to work with you. In addition to the work that I'll talk to you about today on Wearable Labs, as I mentioned, we do some computer vision work. I think a lot of this also has potential application for generalizability across the different PIMCOs. And if any of this sounds interesting to you and you'd benefit, you or your team would benefit from it, I hope again you'll contact me after the talk. Okay, diving into it, how we've used the proof of concept version of Wearable Labs. I should say we've been using this for a couple of years now. We have several kind of larger scale studies starting up. We've been working with this type of data in 3 different patient populations. Our focus on the rehab PIMCO is largely in people with stroke, but we've also collaborated with the COPD PIMCO. And now we have a second project being launched out of our rehab PIMCO. I think Adrienne Sfingos is on the call today. She's leading a pediatric rehab project. So she's looking at how we can use these types of large-scale real-world data to inform recovery after traumatic brain injury in adolescents. And so how we use Wearable Labs to get kind of real-world data on what we call whole person function is by using remotely delivered assessments or devices in 3 different domains. First, in the physical or motor domain, we use Fitbit devices, as Bill was describing, to be able to get daily and minute level measurements on things like step count and heart rate. We also do remote cognitive assessments that are delivered once every 3 months. We have previously used a web app called Test My Brain, or the Many Brains project, that delivers a variety of different cognitive assessments that people can complete on their mobile phone or on a web application. And then we also do monthly psychosocial assessments where we administer promise questionnaires on a monthly basis. And so we have these different heterogeneous data sources, and it was really important for us to, one, be able to manage all of these data and ideally bring them into a single centralized repository. But it was also important for us to do quality control on the data that we were getting, meaning we need to know when people are syncing their Fitbit devices. So if you're not used to wearing a Fitbit device, the way that you transmit that data is you wear the Fitbit, but then you have to actually open the Fitbit app on your phone. You have to sync the device to the app by just swiping down within the application, and only then are the data actually transmitted from the device into the Fitbit server. Once those data are living in the Fitbit server, we then need an application to go into that Fitbit server automatically, pull those data, and bring them back into the repository. And so we really worked with Bill and the TIC to come up with a system that would meet all of these needs simultaneously and streamline the data collection and management processes that are aligned with collecting these types of data. So how do we do this? We begin with the study team, and we feed everything through a REDCap database that will inform the system whether the participant is enrolled and active or whether they've been withdrawn or completed the study. That's what's meant by participant status here. And then that feeds right into Wearable Labs, and it does all these things that I was describing. It provides us with automated data pulls from the Fitbit or Many Brains or Promise servers that we keep all that data in. It provides automated reminders out to our participants, and then it sends all of that data into our data repository. So this lives right along next to our electronic health record data. And this is basically just a schematic of how that all works. So to be able to use the Fitbit, people need a mobile application on their phone. For the Many Brains testing and the Promise questionnaires, they can do those by either email or by phone, by text message. And so Wearable Labs pulls all that data into us. It looks back into the date that the participants last synced their device. And if it's been more than 5 days, it sends them one reminder. If it's then been more than 12 days, it sends them another reminder. And if it's been more than 19 days, it then automatically contacts a member of our study team to get in manual contact with the participant to tell them to sync their device. As you can see on the bottom here, it also provides automated reminders to take or complete assessments, both the cognitive assessments and the psychosocial assessments. So if it sends out a link to someone to be completed and they don't complete that in a timely manner or they don't complete it at all, it'll continue to send them these automated reminders. And then again, it brings that data right back into our repository where it lives right alongside our EHR data. We've also begun to work with Bill and the team to really quantify some of the advantages of Wearable Labs in terms of actually measuring the different types of savings that it's provided. The data that I'm going to show you here is kind of some back of the envelope calculations that we've made while using this system. And importantly, they're only focused on the Fitbit data. So the numbers that you're going to see here aren't even including the time savings or the manpower savings that are coming from managing the cognitive and psychosocial data. So when we did this analysis, we had an ongoing study of 86 persons with stroke. These numbers here aren't particularly important to understand beyond the fact that when we looked at how much time was being saved to measure the Fitbit, to check the Fitbit data on these participants, we estimated that there were approximately 250 reminders being sent per month if you scale this up to a 5-person study or healthcare system. And so if you're looking at what that actually means at this more scalable level, we estimated that you'd be spending over 1,000 hours a month to be able to manage this 500-person cohort if you were manually logging into the Fitbit servers and checking to see whether people were syncing their Fitbits and then ultimately providing more like phone call type of reminders versus using this system. And then when we look at the cost domain, what does that actually mean? Well, if we consider 1,000 hours of manpower per month, that's approximately 6 full-time research coordinators. If you consider that each coordinator makes about $50,000 a year, that's a month, but that'd be about $300,000 a year. And this is also in addition to providing the elimination of human error that occurs through this automation. So no more need for manual data pulls where you're downloading data out of the Fitbit server and then manually, relocating it into your repository or the server that you want it to be in. All this is streamlined and happens automatically. And so what do we actually do with that data? Here's a study that we did last year. This is now published in the Journal of the American Heart Association. We have been able to pull a variety of different types of data from the Fitbit devices. And so since we have such a scalable platform with Wearable Labs, we're able to get this data all together and do some kind of sample or population level studies from these data. And so here you're seeing heart rate along the y-axis in 2 different sample subjects, and then steps per minute along the x-axis. When we get this data, we can partition it into basically 4 different quadrants. We can partition it into what we determine based on the sample as high or low heart rates, and we can also partition it into high or low step rates in terms of steps per minute. And why is this important? Well, when we go through this, we can actually begin to quantify the percentage of time that participants are active and being active in one of these 4 quadrants. So this upper right quadrant represents a quadrant where the participant is showing high steps and high heart rate. So you might think of this as if somebody's going for a run, or if they're walking vigorously, you might expect their heart rate to increase pretty proportionally with their increased step count. This second quadrant, though, is one that I want you to keep in mind because this is going to be important for the conclusions of what we've done here. This is what we kind of consider a problematic quadrant where there's high heart rate, but relatively low steps per minute. So this could be interpreted as kind of an exaggerated physiological response to activity. You're not moving very much, but when you do move, your heart rate starts to really get elevated. Down in the bottom left corner, this is more of a sedentary quadrant where you have relatively low steps and accordingly relatively low heart rate. And then I always call this like the Lance Armstrong quadrant, where you might have high steps per minute, but you have relatively low physiological response to that activity. And so why did we do this? We extracted, as I've just showed, physical activity and heart rate from these metrics, but we're also able to capture things like sedentary behavior. But what we thought could be really interesting to do is start to see if we can use combinations of these different metrics to be able to actually start to subgroup some of our patients into hopefully clinically relevant subgroups that could potentially even respond similarly to targeted interventions at the subgroup level. So the main question that I'm going to show you here quickly over the next couple of minutes is, we asked whether we can use these metrics from Fitbit to identify subgroups of both people with stroke or people with COPD and kind of identifying these distinct health statuses. And so when we did this clustering, we essentially extracted 3 different clusters of individuals with stroke. The green is consistent across all the plots, the purple is consistent across all the plots, and the orange is consistent. So these are the 3 subgroups that we identified. If we start to look at what kinds of metrics here are actually distinguishing the different subgroups, certain things start to stand out. So if we look at our first cluster, we can see here that the first cluster was significantly more active than the other clusters. The participants or the patients in this subgroup show significantly more steps per day than the other 2. They also accordingly show significantly less % time spent sedentary, and they also show more time in that upper right quadrant where they're both recording high steps and appropriately high heart rates. Here you'll see also that when we start to look at that problematic quadrant, that second quadrant where people have really high heart rate responses to low levels of activity, the cluster 1 group here also, or subgroup, also shows relatively low amounts of activity in that quadrant relative to the others. So this is the cluster that we kind of determined to be the active group. These people are showing high steps, They're not sedentary, and they don't have very much time where their heart rate is elevated in response to relatively low levels of physical activity. However, the other two groups we found a little bit more interesting, the other two subgroups here. So if we start to look at these purple and orange groups, they show relatively similar amounts of steps, average steps per day. They show relatively similar amounts of time spent sedentary, and they show relatively low amounts of time in that high activity quadrant where they're recording high steps and also high heart rate. But what was really interesting to us about these two groups is that the main differentiator between them was this time spent in that problematic quadrant where you have the elevated physiological response to physical activity. And so if we look at this here, we see that when the purple group starts moving, their heart rate stays relatively low. They're not spending many minutes at all in this quadrant where you have the elevated physiological response to activity, but that's certainly not true in the orange group where they have nearly double the hours in terms of their percent daytime hours that we see in that purple group. And so this was really interesting to us because this, we think, might allow us to separate things like determining who's sedentary versus who's deconditioned. So certainly both of these groups are not moving much, so we consider them both sedentary. However, the orange group, when they do move, their heart rate starts to really elevate beyond what might be expected. And so when we put all three of these subgroups together, you can begin to see where you might be able to develop personalized interventions targeting each of these subgroups. In the active subgroup, we might need to either just create an intervention that helps these participants to maintain their active lifestyle, or potentially to be targeting other aspects of their mobility, like potentially their walking kinematics. Versus in the sedentary versus deconditioned group, the sedentary group might need a lifestyle intervention to be able to start getting up and being more active, whereas the deconditioned group might need some kind of combined treatment where they need not only a lifestyle intervention to become more active, but something like an aerobic exercise intervention to address that deconditioned cardiovascular fitness as well. So this approach, using this data that's coming in from Wearable Labs, has helped us to really identify these potentially clinically relevant subgroups of persons with stroke. And so if we plot this out, again, here's on the x-axis is the mean number of steps per day, and on the y-axis is this percent time spent in that problematic quadrant where you have the elevated response to low levels of activity. You can see that these three clusters are relatively well defined in these data. We also did this, we repeated this analysis in individuals with COPD that we'd also brought in data through Wearable Labs. And you can see, if we look at those same metrics, that we were able to identify very similar subgroups of persons with COPD based again on differentiation between being active in the green group and then based on that, that percent time spent in the low steps and high heart rate quadrant between the purple and orange groups. And so if we plot these subgroups out, we see a very similar distribution in the individuals with COPD, which is really encouraging to us because, again, this is a completely independent sample of patients. And if we pool it all together, here's what we see. So again, these three distinct subgroups of active, deconditioned, and sedentary patients. And importantly, it's not traditionally, this is essentially how these type of data are looked at, where you might see something like percent time sedentary on the x-axis and mean steps per day on the y-axis. If you just look at these more general metrics where we're not combining these different metrics of heart rate and steps into a single outcome, you can see that's really hard to differentiate these subgroups from one another. A lot of these, those clusters that we showed on the previous slides are no longer nearly as distinguishable between the different subgroups. And so our next steps, just to give some insight here, we are beginning to explore the clinical relevance of the subgroups because these data from our wearable devices and our remotely collected cognitive and psychosocial assessments all live in the same location as our clinical data. We're able to easily pull things over like the 10-meter walk, for example, from our repository to be able to actually look and see how these subgroups might differ in the clinical data as well. We're also really curious about whether these subgroups are maintained longitudinally. So in other words, do people bounce around back and forth between these subgroups, or is there a way that we could identify if a participant in one of the more desirable subgroups starts to drift in a particular direction back toward one of the other subgroups? Can we intervene in a way that prohibits them from experiencing those declines? And then finally, can we start to use some of these combined physical activity and heart rate metrics as potential biomarkers for important health-related events? So in people with stroke, we're often interested in things like risk of having a second stroke, risk of a hospital readmission, risk of a potential emergency department visit. It'd be great to be able to track these things in real time, especially kind of going back to that second point there. If we can see that people are starting to worsen in real time, can we kind of identify these red flag patients and be able to intervene in a timely manner to prohibit some of these adverse health outcomes. Okay, and that's my spiel for wearable labs for right now. And with the last couple minutes, I also wanted to show you some other technologies that we use that I thought might be of interest to some on the call. In my lab, we also work on a lot of new emerging technologies that use computer vision to basically automate and streamline and make more accessible all different types of quantitative motor assessments of various kinds. So what we do is, the goal of this work is to really make it possible to do something like pull your iPhone out of your pocket or use a household recording device like a tablet, record a video of a patient or research participant, and get some quantitative data back that could inform your clinical decision-making about how well or not they might be moving. So to give you an example of this, this is just somebody walking across a lab space, nothing particular going on here other than moving from right to left across the floor. But if we use these computer vision approaches, we can get something that looks like this. So now you can see it's that same exact video, but we're tracking different anatomical locations on that participant automatically. And then we can extract these data in a time series fashion to see how each of these data points are changing over time, and do things like, in this case, measure the person's walking speed, or how much their knee bends when they're walking, or how far they step with each foot. We've done this in a variety of patient populations as well. This is someone with a stroke, and you can see here that despite the fact that they wear an assistive device on their leg that makes them appear fundamentally differently in the video, we're still able to track their movements well. We've also done this in pediatric populations. We were curious about this because these technologies are really trained on kind of stock images that tend to be people without movement impairment and tend to be adults. So we've been doing a lot of pilot testing, seeing whether these algorithms can also generalize to patient populations or to children whose bodies are obviously proportioned quite differently than adults are. But you can see that despite the fact that she is so tiny and proportioned differently than adults, we're able to track this little toddler as she comes toward the camera here really well. This is me. I've shown you kind of some whole body tracking. We're also able to add different models to expand the capabilities of what's able to be tracked. So you can see here, I've added a hand model. And if I do a rapid hand opening closing task that's common on a variety of different neurological assessments, we're able to track that in this home setting with a relatively high degree of accuracy. And people also ask me commonly, well, how good do the videos need to be able to actually get something useful out of this? And so to kind of stack the deck against us and show, you know, really how well this can generalize across all sorts of different recording techniques. This is actually one of the oldest known videos of someone with Parkinson's disease that was recorded over 100 years ago. And despite the, you know, the black and white nature of the video and the poor video quality, we're able to track those oscillations due to the patient's tremor here with, again, these computer vision techniques. So really no requirements needed in terms of technological advances on the video recordings. We can generate also, this is just an intentionally busy slide to show you, we can, once we have those little, what we call key points, those little dots all over the video subject extracted, we can measure essentially anything that you might be curious about. We spend a lot of time consulting with people, learning about what they want to be measuring, and then helping them to build software that'll extract those metrics from their video recordings. So one, I would love to work with anybody who's interested or think they might benefit from this technology. And two, we're really interested with the Rehab PIMCO of starting to integrate some of this data into PMAP so that we could have this kinematic data that's living alongside that what we consider more kind of quantity of activity data that we get from the wearable devices. So if you had this that provides more information about kind of the quality of movement right next to that data about the quantity of movement, we'd have a really nice kind of comprehensive data set about how well these different people are able to move in whatever setting they might be, in home, in the clinic, out in the community. We'd be able to track a lot of different things. So really excited about this technology. And again, if anybody wants to help us get into PMAP, that would be wonderful. But that's it. I will hang up there and bring Bill back, and we'd be happy to answer any questions you might have.
Well, it looks like
Go ahead, Bill.
Go ahead, Ellen.
I was just looking through some of the questions. So if it's okay, Ryan and Bill, I will shoot them your way.
I could see them.
Oh, great.
Like I said, yeah, I was going to address them. I didn't want to do it until after Ryan was finished. And sorry, I can't show my screen because the way this meeting's set up, that only one can show their face, the host. So Rini, your question about using only in-house. So it's only in-house now. Then we add multi-site collaborations later this year. It'll have to be Hopkins's data core. But the long-term goal we had since we went through Hexsite last year is we do think there's an opportunity to commercialize this and make it available to other institutions, but that's a ways off. So in the near term, right now, Hopkins in-house only, multi-site end of the year, and I guess I can now show my screen, but it would be with Hopkins as a data core, and be then running through the study data core using REDCap as the system of record. So did I answer your question if you're still on?
I don't think they can respond, Bill, so.
Okay. Oh,
Yeah.
I'm sorry. Yeah, okay, thanks. Then Adam, you're basically, your question is like the wind underneath my sails, because one of the I have 10
So Bill,
questions
can
in
you
that
just
survey.
read the question, because the attendees actually can't
Oh,
see.
I'm
So-
sorry.
Oh, it's okay.
So Adam writes, since there's so many devices out there, not just brands, but versions as well, would you be supporting them with the devices so that it has a consistent measurement standard? I ask this because it's been my experience that even new versions of the same device model have different outputs, sometimes significant. And so my first response was, again, you're the wind underneath my sails, because that survey I mentioned, I'll put the link in chat. Only 10 questions, but one of them is, would you be interested in a follow-up session focusing on any of these deep dive topics? One of which was addressing questions such as exporting the same data from a wearable twice doesn't give you the same data. So I think that's similar along the lines of what you're asking. And so fill out the survey, and I think we can definitely get something arranged where we can have a follow-up session. I'm going to put the link to the survey in chat right now. But I think we'll also do a follow-up email to everyone, and you will be able to respond to that as well.
Yeah, right. After this, we'll send out the recording, the presentation that you and Ryan put together, and a link to the Microsoft form that you put together with the short survey.
I was hoping, Bill, that you could amplify a little bit of the work you've done with the IRB to facilitate other groups adding on wearable labs, because as a user, that has also been a really significant coup.
What do you mean? Sorry.
Just that you
Well,
have like standardized language that you worked with the IRB.
Oh, for the IRB, yes.
Yeah.
So I do have that, and we will be making that available, some standard language for you to use, along with, we also have a what's called an info sheet. So it's a pretty long PDF with a deep dive of information that you can attach in your IRB eIRB submission. So we'll provide that along with e-form language, as well as for the informed consent.
So for the investigators who are on the call, I actually did this. I incorporated the standardized language and uploaded the sheets and everything. And honestly, I was so surprised that it was approved super fast with 0 queries because of the pre-work that was done to standardize all the work. So I honestly even missed the approval because it was so fast. I thought it was a different change in research that came in. So that work has been really helpful for sort of templating the approach, I think, for the teams. So that will be really nice.
Yeah, I want to make it so it's just super simple and easy for you to do it. And I think once they've done the IRB has reviewed a few of them, I think it'll be even faster.
Yeah.
But the idea is to take the burden off of you, so you don't have to kind of come up with language. We'll provide you with language that has already been approved. Because we did spend a fair amount of time up front going back and forth with the IRB and data trust to try to pre-address questions that would come up, so that when the first submission went through, it actually did go through, I think, get approved pretty quickly.
And so
we'd love
Bill, can you talk about your plans for, like, do you have preset plans for bringing on additional devices, or are these going to be determined by user use cases, people who have an interest in, say, bringing on Apple Watch or, Actigraph or whatever is sort of next.
Well, that's part of what the last kind of time I did an informal survey was about a year ago. So that's why the survey I sent out, I want to get a more updated one and kind of get an idea where the general demand is coming from, where the highest demand. So that's why replying to the survey will be really helpful. But I definitely, I think Apple, it could be, do we go with more activity trackers? Because that's kind of the baseline with almost every study. You want to have some sort of activity tracking information like that. So maybe that means, do we go Apple Watch, but more for BYOD as opposed to the studies provided. But this next highest demand of our most recent survey for devices was spirometry. And so we're down to, we were going to be focusing on one particular vendor, but we may be pausing that to switch to a different one. But again, this is where your feedback is really valuable because we do want to be very demand driven. So where we're going to have the highest impact, that's where we want to support devices. But outside of that, I'm also working on potentially have a collaboration with Stanford with a research team. They're actually building open source connectors, but their purpose for doing that is because they're trying to provide data for a data science project. And so it's kind of a good relationship that we could have with them. We could perhaps outsource some of the development of connectors to them. And I was actually speaking with Microsoft today, and they're escalating up their chain of command when I suggested that they help support maybe a consortium of open source device connectors. So ourselves, Stanford, and with Microsoft half behind it, we might be able to, it's a force multiplier, get more people doing it. We can be able to ramp up much more quickly. Because honestly, right now, the device connectors, it's kind of a Wild West. And I think it's begging for a standardized approach and one, it really should be open source anyway. These things should be proprietary. So that doesn't give you a great answer of what's next, but what it does tell you is that I think, in 4 to 6 months, we can really be accelerating our ability to quickly add new types of devices or new devices within the same device category. And I know also, Ryan, one of the things that Wearable Labs doesn't have that Ryan showed you is having the questionnaire. And so that's also on our roadmap of adding the ability to have ePro forms in there, and even you can even have, I even want to have studies that don't have any wearables. If you just want to do have ePro, we can do that. We can handle the automated compliance for that. And an interesting concept I'm working through a little bit now is, well, let's say 6 months, 9 months before we support some future device that you want to use. If there's a way for us to simply pull in data that is available in Epic, let's say it's blood pressure. We don't support that yet. But what if we allow you to use Wearable Labs to bring in the last measurement taken of blood pressure in Epic and use that and be able to have a dashboard, be able to do compliance and those types of things, and use it as a proof of concept for you to then secure, not have to wait till we actually support the full devices before you can submit for a grant on that basis. We want to be able to accelerate your ability to submit for grants by providing more data that could, be a proof of concept. So those are other ways we're also looking to truly greatly accelerate adoption.
Other questions? I don't see anything right now in the Q&A.
Yeah, I just put this in the chat quickly, but in the Rehab PIMCO, we are nearing completion of what I put in the chat as the function core, which is hopefully going to be a resource where people can just come to us. And if you're interested in measuring really any of these things we've talked about today as part of your trial or as part of your PIMCO or whatever it might be, we're going to be around to just support all those types of things to make it easier for people to measure really whatever they want to be able to measure in the kind of these functional domains. So just let me know if you have any questions. We'd be more than happy to meet and help you get up and going.
Well, thank you to both of you. I mean, the work that you're doing is so extraordinary. And I think, is going to be very instrumental to a lot of teams within and beyond the InHealth program. So really grateful for your time and energy today, and your willingness to collaborate and to help the teams advance. Thanks so much, everybody, and we'll see you next month as well.